All right, let's just dive right into this. Welcome to today's explainer, where we are embarking on a journey to the absolute edge of our neighborhood. Our target? The enigmatic, incredibly distant, and frankly mysterious final planet of our solar system, Neptune. Now, it's a place most of us instantly recognize by its striking color. But as we're about to uncover today, this planet is hiding some of the most terrifying and absolutely fascinating secrets in the entire cosmos.
Now, you'd naturally think that because Neptune is the absolute furthest planet from the warm glow of our sun, it must be the undisputed icebox of the solar system, right? Well, surprisingly, no. The seventh planet, Uranus, actually takes the crown for being the coldest. But don't let that fool you into thinking Neptune is hospitable. As we'll see, Neptune boasts boiling cores, winds that literally break the sound barrier, and extreme atmospheric pressure that causes it to rain, and I'm not kidding here, diamonds.
So here's our flight path for today's explainer. First, the discovery of the mysterious blue planet. Second, the long journey to Neptune. Third, why can't we land? Fourth, Triton, the strangest moon. And finally, number 5, why is Neptune blue?
Section 1. Discovery of the mysterious blue planet, the pen and paper planet.
The story of how we actually found this planet is just dripping with irony. Back in the 1600s, the legendary Galileo actually spotted Neptune through his telescope. But because of the limited technology back then and the sheer distance of the planet, he mistakenly cataloged it as just another star in the background. Fast forward to the 1800s. Astronomers were tracking Uranus, which everyone thought was the final planet at the time, and they noticed something completely bizarre. Uranus was wobbling. It was literally breaking Isaac Newton's established laws of gravity. Some folks actually wanted to just throw Newton's laws out the window entirely, but a brilliant mathematician named Urbain Le Verrier had a different idea. He believed Newton was absolutely right, and that an unseen massive ghost planet was out there tugging on Uranus. Using nothing but a pen, paper, and some incredibly complex math, Le Verrier calculated exactly where this mystery planet should be. When telescopes pointed to his exact mathematical coordinates in 1846, boom, there it was. Neptune is the only planet in our solar system discovered by pure mathematics before it was ever officially observed.
Moving on to Section 2. The long journey to Neptune, crossing the void.
To really understand Neptune, you first have to respect the distance. Neptune sits 5 billion kilometers away from the Sun. That's 30 astronomical units, meaning it is 30 times further from the Sun than we are here on Earth. Because of this mind-boggling distance, it took NASA's Voyager 2 spacecraft 12 long years to reach Neptune, finally arriving in 1989. And get this, to this day, Voyager 2 remains the single, only spacecraft to have ever visited this distant world.
Let's put that massive scale into perspective using a human lifespan, because honestly, numbers like 5 billion kilometers can just kind of blur together in your brain. Imagine you decide to become an astronaut, and you blast off for Neptune on your 20th birthday. By the time you finally arrive in Neptune's orbit, you'd be 32 years old. After doing your research, you turn the ship right around. By the time you safely splash down back on Earth, you'd be 44. That's almost a quarter of a century just for a round trip. So what's it actually like once you get there? Well, surprisingly enough, the gravity on Neptune is incredibly similar to Earth. If you weigh 45 kilograms here, you'd only weigh slightly more, about 50 kilograms on Neptune. But trust me, that's where the similarities end. Because it's a gas giant spinning super fast, a day on Neptune is only 16 hours long. However, its massive orbit means it takes 165 Earth years just to complete one single trip around the Sun. That means a single season lasts 41 years. And because it's so far away, high noon on Neptune wouldn't look like a bright sunny day. It would look like perpetual twilight. Think of Earth right after the sun dips below the horizon. That's roughly as bright as it gets.
All right, Section 3. Why can't we land? The hostile gas giant.
Landing on Neptune isn't just, a tricky engineering problem. It is physically impossible. There are 2 terrifying reasons for this. First, as a gas giant, it completely lacks a solid rocky surface. If you tried to land a spaceship, you just sink through a thick, cloudy atmosphere until you hit a bizarre, churning ocean made of water and ice that is roughly 17,500 kilometers deep. To put that in perspective, our source compares it to Earth's Pacific Ocean, charting at a depth of 11,000 kilometers in scale, but Neptune's depths plunge thousands of kilometers further into absolute darkness. The second reason? Lethal, perpetual storms that would tear any spacecraft to absolute shreds before it even got deep.
And as you sink, you'd encounter this totally bizarre temperature paradox. High up in the outer atmosphere, Neptune is pitch black and bone-chillingly cold.
But as the immense pressure builds, the deeper you go, the temperature violently spikes. Deep inside, scientists believe Neptune's core reaches a staggering 1,500 degrees Celsius. That means the heart of this freezing dark ice giant is literally almost as hot as the surface of our own sun. It's wild.
Now back to those storms we mentioned earlier. Neptune's winds are recorded at over 2,000 kilometers per hour. That is 5 times faster than the most devastating hurricanes ever recorded on Earth. These incredible winds fuel gigantic storm systems, the most famous being the Great Dark Spot. This thing is a swirling vortex of high-pressure destruction so impossibly massive that you could take our entire planet Earth, drop it inside the Great Dark Spot, and it would easily fit, just swallowed whole.
Which brings us to Section 4, Triton, the strangest moon, a frozen terror.
Neptune actually has 14 moons, but Triton is by far the largest and honestly, the most bizarre. What makes it immediately stand out is its retrograde orbit. This means Triton actually moves backwards. While Neptune spins in one direction, Triton orbits in the exact opposite direction. This retrograde motion is a massive clue for astronomers. It heavily implies that Triton wasn't formed alongside Neptune, but was probably a rogue dwarf planet violently captured by Neptune's massive gravity.
But get this, Triton's orbit isn't even the strangest part. It is considered the coldest place we know of in our solar system, with surface temperatures plummeting to negative 391 degrees Fahrenheit. And bizarrely, despite that mind-numbing cold, it has active volcanoes. But unlike Earth's volcanoes that spew boiling, molten rock and lava, Triton features cryovolcanoes. They violently erupt mixtures of freezing liquid water, ammonia, and methane ice. It is a completely alien landscape. The cold is so visceral and absolute that if you were to somehow expose your bare hand to Triton's winds, the severe lack of heat and instant cessation of blood flow would cause your hand to turn as hard as solid stone almost instantly.
Okay, finally, Section 5. Why is Neptune blue? The methane illusion.
So, Neptune's magnificent color? It has absolutely nothing to do with liquid water oceans reflecting the sky like we see here on Earth. Instead, Neptune's atmosphere is heavily saturated with methane gas. This methane acts like a massive planetary color filter. When the faint light from the distant sun reaches Neptune, the methane gas absorbs all the red, orange, and yellow light, and only reflects the blue light back out into space for our telescopes to see. And hey, remember that immense pressure and heat deep inside the planet we talked about earlier? That atmospheric pressure is so incredibly intense that it actually compresses the carbon atoms found in that methane gas, squeezing them together so tightly that they crystallize, which means thousands of kilometers below the swirling blue clouds, it literally rains solid diamonds falling right towards the boiling core. How crazy is that?
Which brings us to the end of our explainer and leaves us with this final, lingering question. How many more secrets are hidden in the darkness of this blue planet? Think about it. We have only ever sent a single spacecraft, Voyager 2, to briefly fly past it over 30 years ago. Everything we just discussed today, the math-defying discovery, the diamond rain, the backwards orbiting ice volcanoes, all of that is based on just barely scratching the surface of this colossal gas giant. So what else is waiting in the freezing dark, 5 billion kilometers from home, just waiting to be discovered? Thank you so much for exploring with me today, and hey, keep your eyes on the stars.